Module 3 Geometry and Measurement. Question 1. Shona is in charge of decorations for an event. She wants to hang the decorations from the ceiling. The ceiling is triangular in shape as shown in the diagram below. All three sides of the ceiling are 23 meters long. Part A. What is the perimeter in meters of the ceiling? We know that the perimeter is the boundary. Therefore, the boundary of this ceiling is 23 plus 23 plus 23, which is equal to 69 meters. The decorations are to be hung from a beam AB that runs across the center of the ceiling, as shown in the diagram below. Part B. Write a calculation that shows that the length of the beam AB, rounded to one decimal place, is 19.9 meters. For this, we are going to use the right-angled triangle shown with a hypotenuse 23 meters, and the base is half of 23, which is 11.5 meters. Using Pythagoras theorem in this right-angled triangle, AB equals square root of 23 squared minus 11.5 squared, and this equals 19.9 meters. Part C. What is the area in square meters of the ceiling? Round your answer to the nearest whole number. Since the ceiling is a triangle, the area of the triangle equals a half times base times height, equals a half times 23 times 19.9. And this equals approximately 229 square meters, correct to the nearest whole number. Shona wants to hang spheres from the beam. Each sphere has a radius of 18 centimeters, as shown in the diagram below. Part D. What is the volume in cubic centimeters of one sphere? Round your answer to the nearest whole number. We know that the volume of the sphere equals 4 over 3 pi r cubed, which is equal to 4 over 3 times pi times 18 cubed. This equals 24,429 cubic centimeters. Part E. Each sphere will contain a light globe. The light globe will be suspended from the beam by a cable. The lower end of the cable must hang above the center of the sphere and be 12 centimeters from each side of the sphere, as shown in the diagram below. The top of the sphere must be 15 centimeters from the beam. What is the length of the cable in centimeters that will be required from the beam to the light globe? Round your answer to the nearest whole number. We can draw the radius from the center of the sphere, as shown, to form a right-angled triangle with a hypotenuse of 18 centimeters and the top side 12 centimeters. Using Pythagoras theorem in this right-angled triangle, x equals square root of 18 squared minus 12 squared, and this equals 13.42 centimeters. We know that the distance from the center of the sphere to the beam is equal to 15 plus 18, and that is 33 centimeters. Therefore, the length of the cable is 33 minus 13.42 equals 19.58 centimeters, approximately equal to 20 centimeters, correct to the nearest whole number. Question 2. Shona will place cylindrical balls on each table at the event as a centerpiece. Each cylindrical ball has a radius of 6 centimeters, as shown in the diagram below. Each ball has a volume of 1,244 centimeters cubed. Part A. Write a calculation that shows that the height h of one cylindrical ball, rounded to the nearest whole number, is 11 centimeters. We know that the volume of a cylinder equals pi r squared h. Therefore, the height equals the volume 1244 divided by pi times 6 squared, and that gives us approximately 11 centimeters, correct to the nearest whole number. Part B. A candle, also in the shape of a cylinder, is to be placed upright inside each bowl so that it touches the base of the bowl. The candle has a radius of 3 centimeters and a height of 18 centimeters. Once the candle has been placed inside the bowl, the remaining volume of the bowl will be filled with sand. What volume of sand in cubic centimeters is required to fill the cylindrical bowl once the candle is placed inside it? Round your answer to the nearest whole number. Notice that the height of the cylindrical bowl is 11 centimeters, so the sand is going to go up only to the height of 11 centimeters. So the volume of sand equals the volume of the bowl minus the volume of the candle. That is 1244 minus pi times 3 squared times 11, and that equals 933 cubic centimeters. Part C. Each bowl is to be placed on a circular plate. Below is a diagram of a bowl on top of the plate, as seen from above. The area of the plate that is not covered by the bowl is shaded. The ratio of the area of the base of the bowl to the shaded area is 4:5. What is the area in square centimeters of the plate? Round your answer to 1 decimal place. Let's write the ratio between the area of the base of the bowl and the shaded area equals 4:5. We know that the area of the base of the bowl equals 36 pi. The shaded area is going to be equal to 36 pi times 5 divided by 4, which is 45 pi. Therefore, the area of the plate equals the area of the base of the bowl plus the shaded area, and that gives us 81 pi, which is approximately 254.5 squared centimeters, correct to 1 decimal place. Question 3. Aisha will fly from Brisbane to Adelaide for the event. She can take a direct flight from Brisbane to Adelaide. Brisbane is 918 kilometers north and 1,310 kilometers east of Adelaide. Part A. Show with calculations that the bearing of Adelaide from Brisbane, rounded to the nearest degree, is 235 degrees. We are going to draw the north at Brisbane. We draw the direct distance from Adelaide to Brisbane, and here is the bearing of Adelaide from Brisbane. Now we need to calculate angle theta inside of the right angle triangle formed. So tangent of theta equals 918 divided by 1310. Therefore, theta equals 35 degrees. So the bearing of Adelaide from Brisbane equals 270 minus 35 degrees equals 235 degrees. Part B. Aisha could also take a flight from Brisbane to Adelaide via Melbourne, as shown on the diagram below. Melbourne is 1,370 kilometers from Brisbane on a bearing of 211 degrees. What is the distance in kilometers between Melbourne and Adelaide? Round your answer to the nearest whole number. Let's draw the distance from Adelaide to Brisbane, and the angle formed is angle alpha. Alpha equals 235 degrees minus 211 degrees equals 24 degrees. We are going to use Pythagoras' theorem in the right angle triangle from part A to calculate the distance from Adelaide to Brisbane, AB. That is square root of 918 squared plus 1310 squared equals 1,599.63 kilometers. Using the cosine rule in triangle ABM, we can calculate the distance from Adelaide to Melbourne, AM, as shown. And this is 657 kilometers, correct to the nearest whole number.